Okay, who remembers what we did yesterday?
SOHCAHTOA.
Exactly. SOHCAHTOA. And what did we use that for?
Right triangles.
Exactly. So to do a couple review problems from yesterday then, if I gave you this right triangle, stop speaking. Okay, right triangle, remember, because it has that little box in the corner. And I labeled it A, B, and C, and I said that the measurements were as such, 21, 29, and 20, and I asked you to find the cosine of C. Does anybody remember what we would do? Well, here, I'll help you out. Remember the cosine, we're going to use ca for SOHCAHTOA, so that means we're going to take the cosine of, that's our theta, because I said look for cosine of C, equals adjacent, 20, over hypotenuse, 29. So if we reach over to our calculators, let's make sure that we're in degrees again, and we plug this stuff in. What did you guys get for an answer?
46.4.
46.4. Degrees?
Yes.
Good. That's what I got too. You guys are awesome today. Okay. If you remember towards the latter part of the lesson, I gave you a different triangle. And I asked you to, given this triangle, find x if the, make that a right angle for you. If this angle is 59 degrees and your hypotenuse is 17. Can we do that? I think so. Okay, let's use tangent this time, our TOA part. If we take the tangent of 59 degrees equals the opposite, x, over adjacent, 17. And if we plug that into our calculator, and we type in tangent of 59 degrees times 17, what did you guys get?
14.57.
Yes, that's exactly what I got too. Wait, what did you say it was? Okay.
14.57.
There we go. Awesome. So today's lesson is we're going to learn how you can apply this in real life. And the goal is that by the end of the lesson, 3 out of 4 times, you're going to get the correct height. I wanted to go outside today and measure, we were going to find out how tall this building is. Unfortunately, it's raining, so we're stuck inside. But we're going to find out how tall the wall is. How exciting is that? Okay, so everybody's going to need a theodolite, and those are these. Okay. The first step of what we're going to do is we're going to pick a spot on the floor. And we're going to have to measure it, okay? So, we're going to measure up here, so if you guys want to stand up. And Dylan, you might want to take your chair in because otherwise I might trip over it. Thank you. Why don't you two pick a spot somewhere in the student's vicinity, anywhere you want. Let's go with his because it's a little bit farther away and our measurements will work out a little better. Is that okay?
Okay.
Okay. Chris, if you want to stand at this end and hold that near the floor. Where is your spot?
Right.
Right where? Measure it. Right there. Just for the purpose of making it easier, would you be offended if we moved it to 10 feet even? That's fine. Let's mark that with a pen. We'll make sure not to move that. Okay, we can put the tape measure away. So this would be our distance away from the wall, correct? Right?
Yes.
Okay, so, oops, sorry. I'm just going to write down our 10 feet away from the wall so we don't forget that we were 10 feet. 10 feet was our distance. Okay, now is when we're going to use the theodolites. To use these, I want you to take and you're going to stand at the point that you measured already where the pen is. And I want you to line the base, the top of theodolite to your eyeball, and I want you to point it up until this end is directly in line with the corner in the ceiling. And then, once you're all measured up and you're like this, you're going to clamp down the string, and then you're going to read what degree angle it was. Whoops, here, Dylan. Do it that way. Try it that way. And then let the rock hang freely. Yep. And then line it up with your eye.
Okay.
Until it's up in the corner. Are you doing it, Chris?
Yeah.
Hope you're getting along okay. And then when your rock kind of stops moving, go ahead and clamp down with your, right there. You clamp that down with your finger. Chris, are you able to do that over there?
Yeah, I got it.
Perfect. What does your guys' angle measurements equal?
I got 110 degrees.
Let's do the one that's less than 90.
Oh, okay, that'd be 70.
70 degrees. And what's yours, Chris?
I got about 72.
72 or 70
70
as well?
as well.
Okay. Wow, good job, guys. Mine was also at 70 when I measured before class. Okay, now we can go ahead and sit back down. That part is over. So now we're going to find out how tall the wall is. So if we draw our picture, we did have an extra credit problem like this on your homework yesterday, so maybe you'll recognize this. There's the wall, and here is me. Or you, can be both of us. Okay, and from our eyes, and I'm not a very good artist. What was our distance again?
10 feet.
Ah, thank you. Perfect. Okay, and our angle was what again?
70 degrees.
70, perfect. Okay, using SOHCAHTOA, can we find X? I think we can. Let's try it. Let's do tangent again. Tangent of 70 degrees equals our opposite over adjacent, 10. So, we'll go ahead and plug that into our handy dandy calculator. And looks like then you take tangent of 70 times 10. Okay. Looks like I got, did you guys get the same answer as me? 27.5?
Yes.
27.5. What's our label again? Feet.
Feet.
Perfect. Okay, so from the top of my head to the ceiling is 25 feet. Think that's the right answer? Seems a little bit outlandish, doesn't it?
Yeah.
All right, let me show you. There's a special trick to the theodolites. When these measure, if I was to measure straight across, that would be 0 degrees, right?
Right.
Look again. What does my theodolite say?
90.
Wow.
90. What? That's not the same thing. 0 doesn't equal 90. So what this does is this actually measures from perpendicular to the ground and up. And that's actually not the measurement we want. So what we need to find, how to get the correct angle, take 90 degrees minus the angle that you got, which is 70, equals 20 degrees. And we put that instead. So if we erase it here, put 20 degrees, and we erase it here, and put 20 degrees. Let's try that instead and see what we get. Put in 20 degrees. Oh man, did you guys get 3.6 feet?
That sounds a little more
Yes.
accurate.
3.6 feet. That sounds definitely more accurate from my eyeballs to the ceiling. 3.6 feet. That sounds way better. Okay? So, are we done? The wall is 3.6 feet tall.
Okay.
Yeah,
It's still wrong.
I think all of us are over 3 feet and none of us are crouching over. So, what do we notice? From the eyeball to our angle measurement was only this measurement right there. We still have all of this to account up for. So how do we do that? Well, if we take from my eyeballs to the ground, that's going to be the rest of our distance. So, I got 70 degrees as well. I am about 5'5", or I'm 5'7", so it's 5.5 feet. 5.5 feet is what this is. Okay, that's right there. If we have this and we have this, can we find the total?
Yeah.
I think so. 3.6 plus 5.5, we get, bring down our, I'll go ahead and do it long for you. Drop down our 1, 9.1. I heard it out in the crowd. You guys are so smart today. Does 9.1 feet make sense for this ceiling?
Yeah.
I think
Yes.
so. I think so. Okay. So yesterday we learned what SOHCAHTOA was. What did we do today?
We learned about how to use it in real life.
Exactly. Perfect. Well, do you think we can find the height of some other stuff too? What if I was an architect and they told me they wanted me to build a slide for a really small child, and they could only go 3 feet in air, the ladder goes straight up, and the slide, it only goes down at 80 degrees. Whoops, I wrote 89. 80 degrees. And I needed to know how much metal I needed to buy. Can I do that? Isn't it the same thing we just did over here?
Yeah.
Yes.
Awesome. So you guys will have some homework on some real life applications, and we will grade them tomorrow. Chris.